Okay, so we've talked about physical and chemical changes, and we've seen how physical changes, matter changes its appearance but not its composition. But in chemical changes, matter does change its composition in what we usually represent as a chemical reaction. We have our reactants turn into certain products. But even though we have a change in composition, we can be for certain that matter is neither created nor destroyed in a chemical reaction. It's simply reorganized. And this was a theory devised by Antoine Lavoisier. So let's see an example of when we have butane in our lighters ignite with the oxygen in the air. We get carbon dioxide for our product and water. But what we can be sure of is that the mass of our reactant is going to equal the mass of our product because we are conserving mass. So if we had 58 grams of butane ignite with 208 grams of oxygen, we end up with 176 grams of carbon dioxide and 90 grams of water. Notice that they both add up to 266 grams on both sides. So we see that our mass of the reactant is equal to our mass of the product here. Now suppose that we have 12 grams of natural gas and we ignited that with 48 grams of oxygen in the flame, and we end up producing 33 grams of carbon dioxide. Well, how many grams of water form? So in a chemical reaction, this is written like so. We have our natural gas combust with the oxygen to give us carbon dioxide and water. And we're given that there's 12 grams of natural gas and 48 grams of oxygen. And we produced 33 grams of carbon dioxide. Well, how many grams of water formed? And that is our unknown. Well, we know that the mass of our reactants here is going to equal the mass of our product here. So this mass here, 12 plus 48 is 60 grams, is going to equal 33 plus x. And x, in this case, is our mass of water. Now simply we rearrange this to solve for x, and we end up saying x is 27 grams, or the mass of water formed is 27 grams, which is consistent with our law of conservation of mass. Okay, so go ahead and try this to see if you understand the law of conservation of mass. A chemist forms 16.7 or 16.6 grams of potassium iodide by combining 3.9 grams of potassium with 12.7 grams of iodine. Show these results are consistent with the law of conservation of mass. Well, the fact that this says forms automatically means I am making potassium iodide. That is my product. And this is done by combining potassium with iodine. So I have 3.9 grams of potassium and 12.7 grams of iodine, and I end up making 16.6 grams of potassium iodide. So now I want to make sure that the mass of my reactant is equal to the mass of my product or products. In this case, we have only one product, which is fine. It does not matter because they're combining. We just have to make sure that our mass is consistent. So when we say that 3.9 plus 12.7 grams is equal to 16.6 grams, is that correct? And we find yes. 16.6 grams of reactants form 16.6 grams of product. So this is consistent with the law of conservation of mass.